Your Honor, I now call the Go, NoGo player to the stand. Now, you are the Go, NoGo player?
Yes, I am.
Have you ever tested the defendant?
Yes, I have.
Would you describe those tests, please?
Certainly. At the time, my concern was with the stability of the reference IC. Using an approach outlined by my colleague, Bob Houston of Fairchild, I stored the response patterns of the reference IC in the memory of the test system. I then used these stored responses, rather than the reference IC, for future comparisons. This freed the test from any later failures of the reference IC. A printout of the test data has been made available to the court. I have also prepared a block diagram of the microprocessor for your reference.
Here you are. Yes, I see that there are only some 5,000 words in this test pattern and less than 2,000 in this one. Now, I have seen memory test patterns over 16 million words in length. Now, since the microprocessor is so complex, why is this program so short?
In these tests, it was my objective to find a minimal length test pattern which would also exercise the basic functionality of the microprocessor. The second test you see was recommended by the IC manufacturer.
So, your object then was not to find out if the microprocessor always works, but to find out if it works at all.
It could be stated that way. It is only fair to note, however, that once all the microprocessor's failure modes are known, the test program can be shortened to test only for those failures.
And have microprocessors, including the defendant, come to that stage yet?
No. Although the shorter tests suggested by the IC manufacturers are based upon some failure analysis, as well as some a priori reckoning of where failures might occur, one must also consider that a typical microprocessor contains only 72 bits of internal memory compared to thousands in a memory chip.
Now, is it not also true that the shorter test patterns were concocted by the IC manufacturers to avoid a process whereby I shuttle my tart tray to and from the test system's memory? And is it not also true that this so-called pattern burst process is at most only 5% efficient?
True. Your tart trays can hold only 2,000 tarts, and these shorter patterns make that number quite efficient. It is also true that these shorter tests test all the microprocessor's basic abilities. They perform conditional jumps. They add numbers and carry bits. They increment and decrement the registers. They transfer blocks of data between registers. They rotate data, both left and right. And they execute program interrupts. These patterns are to the microprocessor what a checkerboard pattern is to memory testing. They are compact and very useful, but by no means complete.
What do you feel is lacking in the shorter test patterns?
Coverage. These patterns will reveal a static fault, such as a stuck at 1. They will also reveal a section's inability to perform its basic function. Many field failures, however, are due to more subtle factors, such as propagation delay variation with data load, sense amplifier recovery, and other factors not yet identified. Some of these, called instruction sensitivities, are revealed only by a massive infusion of input patterns.
Well, do you feel then that formula-generated patterns, rather than arbitrarily assigned patterns, are the proper method with which to test microprocessors?
Formula-generated patterns, sometimes called algorithmic, are certainly very useful, but like a strong tree in a monsoon storm, its flexibility is sometimes limited.
How so?
The process of finding new failure modes, isolating their causes, and, if fortune smiles upon you, creating a compact functional pattern for production testing requires many tools. One such tool is the random logic pattern generator.
Ah, you mean a pseudo-random gray code generator, which changes only one tart from one input word to the next.
No. Gray code generators also depend upon a fixed formula. I refer to those generators whose tart trays are loaded with tarts arbitrarily specified by the programmer. Such word generators are useful in so-called backdoor characterization schemes. In these schemes, a new failure is found in the field, and one needs to develop a short pattern to test for that mode. If one has an algorithmic generator, he may have to find a whole new formula.
Do you find any other flaws in the formula-generated pattern technique?
Only that in some algorithmic configurations, one may only sample the microprocessor's address lines and not its data lines.
Thank you. Your witness.
Good to see you again, NoGo player. As I recall, the last time we met was at my engineering characterization. And as I recall, we performed some tests together.
This is true.
Would you mind telling the court the specific approaches you chose in programming my tests?
I would be most pleased. I began with a formula-generated pattern approach. I stimulated your reset input, a task which took very few words to accomplish. I then exercised your program counter through its entire range. Since it can assume 65,000 different values, and since each value requires 4 clock cycles, the test took over 250,000 clock cycles.
So, you tested my program counter completely.
Objection, Your Honor. The only instruction executed by the defendant in that test sequence was a no-operation instruction. The operation of her program counter was not tested under a program load as would be encountered in an actual application.
Objection noted. The witness will answer the question.
Your program counter was tested for functionality. It is true that varying loads of operation would vary your total charge, thus changing your total capacitance and thereby altering your propagation delays slightly. However, to have run a complete program on each of your possible program states would have multiplied the test times beyond the scope of my abacus.
Did you test any of my other functional blocks?
Yes, I loaded your internal memory registers with alternating ones and zeros. Then I transferred these patterns among your various registers.
Until you tested my entire memory.
Objection! Loading the memory registers with a long series of transfer instructions is an unlikely end use for a microprocessor.
Objection noted. The witness will answer.
Yes, within the limits of test time.
I further recall you exercised my stack pointer through its full range and used some 250,000 clock cycles doing so. Then you brought out my high and low memory by transferring them to my stack pointer.
This is true.
Then you exercised my arithmetic logic unit many times over, using over 50,000 clock cycles. Then you loaded, read back, rotated, and transferred the contents of my accumulator. Did I pass these tests?
Your responses were like sweet orange blossoms caressing the setting sun.
Did I not also pass several shorter tests that were applied by the arbitrary pattern tart generators?
Yes, you did.
So, in essence, I have already passed the most rigorous electrical tests in the IC testing industry.
Yes, you have.
Thank you, NoGo player.